Given that n can be any integer such that n is greater than 1, prove that n cubed plus 3n squared plus 2n is always a multiple of 6. So this n cubed plus 3n squared plus 2n, what could we do with that? Well, I could factorise an n outside because all of those terms have n inside them. And then actually I noticed that I could factorise that quadratic as well. Two numbers that multiply to make 2 and add to make 3 is 1 and 2. So this cubic expression is actually the same as n times n plus 1 times n plus 2. And hopefully you notice something special about these three integers. They are consecutive. These are consecutive integers. Now, a couple of things we know about that then. There must be at least one even number inside there. If this is even, then that's odd and that's even. Or if this is odd, this would be even and this would be odd. There must be at least one even number there. And crucially, that means a multiple of 2. All even numbers are multiples of 2. Right, the second key fact we've got here is whenever we have 3 consecutive numbers, at least one of those must be a multiple of 3. For example, it could be 3, 4, 5. Those could be the 3 consecutive numbers we're talking about. Or it could be 4, 5, 6, or it could be 5, 6, 7, or it could be 6, 7, 8. In every single possible case, there's always going to be one multiple of 3 in those 3 consecutive numbers. Again, if you're not convinced right now, write down 3 consecutive numbers you can think of. So right now, write down 3 consecutive numbers. I'm going to write down 17, 18, 19. And you should find that at least one of them is a multiple of 3. It has to be when we have 3 numbers. So there is also one multiple of 3. And in our conclusion, if we have a multiple of 2 and a multiple of 3, when they are multiplied together, they are going to give us a multiple of 6. So, when a multiple of 2 and a multiple of 3 are multiplied, they give a multiple of 6.